This is the friction practice problems. I'm going to solve problem number 1 and problem number 4. So, problem number 1. A box weighs 350 newtons and has a coefficient of friction of 0.3. What force is needed to slide along the horizontal floor at a constant speed? So, the first thing we're going to do is, let's draw the box. And I'm going to represent the floor by those lines. And the information it says is the weight of the box, so by the center of mass, I'm going to draw the vector of the weight straight down, and this is 350 newtons. That's the weight of the box. The coefficient of friction is 0.3. So the coefficient of friction, I usually like to mark the contact between the box and the floor someplace, and to label the coefficient of friction, mu, which is 0.3. So the force needed to slide the box. So it's looks like will be a F, which apply force, and the box is sliding at constant speed. Okay, so this key statement here, constant speed, means the system is in equilibrium, which means that the forces are in equilibrium. So to see a little bit better, let's finish the free body diagram. So that's, you have your normal force. So it's a force that is normal to the contact surface. And if I have the coefficient of friction, I will have a friction force that opposes the motion. So if it's the motion is going that direction, being pulled by the applied force, so there is a opposite force, which is the friction on the other direction. So now what we are going to do is this statement that says that constant speed really helpful to solve this problem, because we can state that the sum of all the forces up is equal to the sum of all forces down. So what we have here, up, we have Fn is equal to 350 newtons. So the normal force is equal to the weight force. And also, because the system in equilibrium do the constant speed, the sum of forces to the left is equal to the sum of forces to the right. So which means that I don't have more than one to add. So the only force that I have on your left here is the friction force, and the force that I have on the right is the applied force. So it's very clear that in order to find the applied force, that is the force that I'm looking for. What force is needed to slide the box? I'm looking for this. So if I find the friction force, I can solve this problem. So we know by the friction force formula relate to the normal force and the coefficient of friction, we can do this triangle here, that the friction force is mu Fn. Okay, so to find what we are looking for is the normal, kind of got lost here. 3, 2, 1, recording. So what I'm looking now is the friction force. So the friction force is mu times Fn. So the friction force is mu, which is 0.3, times Fn, which is 350 newtons. So, bring my calculator. 0.3 times 350 is 105 newtons. So, the final answer is the applied force, or the force needed to slide this box along the horizontal floor, is 105 Newton, and that is my final answer. Problem number 4. A 450 Newton box is pulled along the floor at a constant speed with a force of 110 Newton, acting along a rope inclined 20 degrees above the horizontal. What is the coefficient of friction? So first, we are going to translate this story into a diagram. So number 4, and we are going to draw a box. The box is sliding along a floor. So this is the floor. And the other information is that the weight of the box is 450 newtons. So by the center of mass, draw a vector straight down to represent the weight of this box, 450 newtons. And is being pulled by a force of 110 newtons along a rope that is inclined 20 degrees. So that is a rope attached to the box, 110 newtons, that makes 20 degrees with the horizontal. It is asking the coefficient of friction. So the coefficient of friction is mu, is between how rough is the surface, the contact surface between the box and the floor. So first, we need to complete this free body diagram. So what is missing here is the normal force, because this box is on a contact surface. So we have a normal force. So normal force makes 90 degrees with the contact surface. So if we have a force that is pulling the box to one direction and we have a coefficient of friction, so we have a friction force that opposes the motion. So go to the other direction. To complete this free body diagram, we need to find the components of this vector because it's not aligned with the horizontal and vertical grid. So to do that, you need to draw your vertical component and your horizontal component. So your free body diagram for this problem is complete. Next, we need to calculate the components of this vector. So we are going to find the value of fx and fy using sine and cosine to find the components. So fx is adjacent to 20, so your fx is 110. Fx, so adjacent is cosine of 20, and your vertical component is the opposite, so is sine, so 110 sine of 20. So doing a calculation, fx is 103 Newton, and your Fy is 110 times sinus of 20, approximately 38 Newton. Round a little bit. So this information we need to keep in our pocket because it's going to be very useful pretty soon. So next, so we did the free body diagram. We calculate the components of this vector. Now we need to use this very important statement, constant speed. Constant speed means that the system in equilibrium. So if the system in equilibrium, you can state the sum of all forces up is equal to the sum of forces down. The sum of forces to the left is equal to the sum of forces to the right. So what do we have in the vertical position? We have Fn, we have the weight, and we have Fy. Since Fn and Fy are both at the same direction, we are going to add them. So Fn plus Fy is equal 450, force 2 at the bottom. Now, this one here, we just have Ff and Fx in the horizontal position. So, the left is equal to the right. So, keep in mind what we are trying to calculate. So, is the coefficient of friction. So, what is the formula for the coefficient of friction? So, the formula for the coefficient of friction is friction force over Fn. So, we have the friction force, which is Fx, is this number, this value. To find the Fn, we need to solve this equation. So, your Fn is 450 minus Fy, which is 38. So 450 minus 38 is, so this is 412 newtons. So going back to the equation here for the coefficient of friction, so my Ff is Fx, we have to, Fx is 103 newtons over Fn is 412 newtons. So we are going to cancel those 2 units. And my coefficient of friction is, which is 0.25. And notice that coefficient of friction does not have any unit because those 2 units, they cancel each other. So that's your final answer.